And welcome to those people who are joining us via Zoom tonight. I think there are a couple of non-members, so welcome to you too. If you'd like to know more about the Society, of course, please do ask during the evening. Just a couple of announcements which we usually make. For those who are not familiar with our premises, the fire doors are in the corridor behind that wall there. And ladies' toilets are on that side, men's toilets on that side. So the plan for this evening is our lecture will go for approximately 45-50 minutes, and then Patrick will take questions. And I think at any time, think about your questions. This is going to be a very interesting talk, I think. So I'll introduce Patrick. Patrick Moss is Deputy Head of the School of Earth and Environmental Sciences at the University of Queensland. He is also a member of our council and is a member of our Scientific Studies Committee. So we thank Patrick very much for coming here this evening to talk to us about his research on the megafauna of Queensland. Before I hand it over to Patrick, I should just remind members who are on Zoom, if you could please turn off, make sure your microphones and your cameras are turned off. And anyone here in the audience, if you've got your mobile phone turned on, please turn that off. Thank you. So this evening, it's a topic which has been very contentious, as you'll hear, for Australian archaeology and palaeontology. Imagine yourselves if you were in Queensland, say 50,000 years ago, walking through the bush, and you may come across a 3-ton marsupial or a 6-meter goanna or a giant kangaroo weighing more than 200 kilos. That's what those creatures were here. They were the inhabitants of Queensland. So I think this evening we're going to hear about the complexity associated with how their demise took place and some of the debates around why they disappeared from our scene, why we don't see them today. So with that, can you please join me in welcoming Patrick Moss?
Okay, great. Microphone's working. I'd just like to firstly acknowledge acknowledgement of country. So just to acknowledge traditional owners and custodians of the lands on which we meet, which I think are the Yagara Turrbal people, and pay respects to their ancestors, the descendants who continue cultural and spiritual connection to country, and we recognise the valuable contribution to Australian and global society. So I'll move on to my presentation now. And this. And we've got that first difficulty. It's not working.
Okay. I think so. Unusual.
That was working before.
Yep. Okay, we might have to do it this way. Is that okay?
Just double check.
Yeah,
no,
it's working now.
Okay.
Sorry.
All right, that's okay. All right, sorry about that. That first difficulty. Okay, so what I'm going to talk about is not necessarily directly the megafauna. Certainly the research that I'm discussing is related to it, particularly providing environmental context and potentially providing some indirect evidence of their demise. And I'll get to that a little bit later. Now, this is work with a range of collaborators, which I've put up here as well. So again, my name's sort of up front and center, but it's certainly a number of people involved in this research, and I'll be presenting in some of their data, and I'll acknowledge them as I move through. But in particular, Scott Hocknell at Queensland Museum, one of the key megafauna sites, South Walker Creek that I'll come to, he's one of the key people working that area. Colleagues at University of Adelaide, John Tibby and Cameron Bath, for some of the work on North Stradbroke Island. And in Tassie, so I'll do a trip down south for part of the talk, Forest Practice Authority, so Peter McIntosh and Adrian Slee, and then Quandamooka people on Minjerribah and North Stradbroke Island as well have also contributed to some of this research. And a lot of this research is also ongoing. So I'm not going to answer that question, climate people or both. I do have my views about that, which I'll come to, but I'm very much in the camp that I don't think we can have the answer to that yet. Some of my colleagues may disagree with that as well, but I think that we still need to do a lot more research. And actually Queensland is probably one of the key areas that we need to sort of get more data from to resolve this debate as well. All right, so I'm going to give you a brief background of this period around about 50 to 40,000 years ago where the megafauna disappeared. And I'm going to focus on work at South Walker Creek in central Queensland, and basically provide some background in terms of my research. I'm a palynologist, so I look at fossil pollen and reconstruct past landscapes. And that's really important to conceptualize what type of environment were the megafauna existing in, basically. Then I'm going to focus on eastern Queensland and talk about a couple of old sites. One of the sites was my PhD project, and another fairly contentious site that I also worked on as well. So a couple of new sites that are just being worked on by a current PhD student of mine, which is in central Queensland, and potentially overcoming some of the issues that we have finding in particularly suitable swampy areas. And then a little bit closer to home, some work that's currently underway in southeast Queensland on Minjerribah and North Stradbroke Island. Then, as I said, I'll do a quick journey south and look at another site that may provide some indirect evidence of megafaunal extinction in Tasmania, and also providing that environmental context as well, and then hopefully sum everything up. All right, so the first thing in Australia, between about 50 to 40,000 years ago, there is still a bit of a question mark about that, but we had basically extinction of 97% of a group of large animals. So not just marsupials, but also large reptiles and birds, and generally above about 44 kilograms. There's also some evidence that they may have decreased in size. So eastern grey kangaroos during this time period were significantly larger than what they are today. Koalas may have been larger as well. And basically your main megafauna species that are left are the red kangaroo and emu, essentially would sort of fit under that category. So obviously there's a key question about why they disappeared. What was the key factor? So as Rafni suggested before, it's one of the key debates in Australian archaeology and palaeoecology. And there are three key theories: people, and a sort of blitzkrieg hypothesis that Tim Flannery's put forward, which is the direct hunting, that people arrived and thought all the Christmas had come at once, with these large, pretty dumb animals that you could walk up to and take out pretty quickly. Or it could also be associated with habitat modification or a combination of that. So new ignition source, changing the vegetation, and basically the food that the megafauna relied on basically disappeared, and we saw a collapse in sort of ecosystems. Climate, basically that it's a longer term trend of Australia drying out, and it just coincided with human arrival, or both a combination of both human impact and climate change. And I will put my hand up and say that I'm in that last category. I think we need to invoke both factors to explain megafaunal extinction, but I do recognise that we still need to do a lot more research on that. I guess it's also sitting on the fence category as well. I mean, one or the other is probably going to be more important, but I think both do play a very important role. So, still being debated. One of the key ways to resolve the debate is also working about when people came into Australia. So most records sort of go back 40 to 50,000 years, but we have more recent evidence from Northern Territory of people arriving as early as 60 to 65,000 years. And that does create some issues with the human causation, because then you've got about a 20,000 year overlap between people and megafauna. So you can't really say people arrived and megafauna disappeared with that scale of overlap as well. That's one of the reasons why I'm sort of probably moving in that both category. And, you know, we only have one contentious site, Cuddy Springs in New South Wales, which has evidence of artifacts and megafauna together. And so, you know, we don't have that evidence of people directly hunting, or a lot of that across the Australian continent, people directly hunting or interacting with megafauna. May well be out there, we still need to research, but again, there's a lot of gaps, is what I'm sort of suggesting through here. So where do I come in? Well, basically I'm providing that environmental context. So what was the landscape like at that time period? Can we pick up evidence of climate change? Can we pick up evidence of human impact? And can we also pick up evidence of megafauna? And there is one little proxy or type of evidence that we can use that may suggest that, but that's also highly contentious as well. So I think I roughly sort of gave a good introduction to what Australia was like 50,000 years ago. So Sahul, which is sort of the geographic name for PNG, Papua New Guinea, down to Tasmania and Australia, was all connected. So you could basically walk all the way from Port Moresby all the way down to Hobart without getting your feet into salt water. You'll also see a couple of big lakes, so Lake Carpentaria, Bass Lake here, but also places like Kimberley's, so much further or lower sea levels, so it's probably about 70 metres lower sea level. And we do have periods with even lower sea levels, so 18,000 years ago, during last glacial maximum, sea levels were about 120 metres lower than today. So the islands, Fraser Island, Stradbroke Island, were all connected with the mainland. Moreton Bay was a dry plain, and you probably would have needed to go about an extra 30 kilometres further east to get to the coast at that time period. So, you know, it is a dramatically different world. Also a lot drier, or suggested to be a lot drier, although some of the work that we're doing suggests we might need to modify this as well. So deserts just didn't completely take over Australia at this time period. It's a little bit more nuanced than that. And some of the research that we're doing in North Stradbroke Island sort of providing that information. And these are the guys that we're talking about. So again, people arriving 65, 50,000 years ago would have sort of dealt with Diprotodon. So think of a wombat, size of a rhino. We had the original drop bear. So again, does exist, but 55,000 years ago. So this was a carnivorous possum, about the size of a panther. And then we had the really terrifying megafauna. So this is Megalania, so ambush predator. And there's also evidence that we had Komodo dragons. So there might have been at least 2 subspecies of this large lizard present. And then Genionis, which is basically, I think, its closest relative is chicken, or genetically related to the chicken. So giant chicken was occurring there as well. So all of those guys and a range of other animals disappeared at that time period. So again, dramatically different from what we see today. So one of the key sites, this was published last year in Nature Communications, which was led by Scott Hucknall, was South Walker Creek in central Queensland. And again, that's a reconstruction of that location. Scott sort of worked on the animals. I worked on the plants in the background, sort of working out what was located there and what was the landscape. It was basically a billabong. And basically there was this giant salty, which was ambushing the megafauna and dragging them there. And we looked, Scott basically and others looked at the remains of the Queensland Museum of those to reconstruct what animals were present. One of the really interesting things as well is that, yes, we had saltwater crocodiles, which is your other megafauna. There's your Megalania, but we also had 2 other species of crocodiles, crocodilians. So a terrestrial crocodile and the suggestion of a sort of more arboreal crocodile as well. So tree climbing crocodile, so which quite scary. But again, that's evidence sort of emerging, and we're digging up new species before all the time. Now, The site is located in central Queensland, so the star marks the spot. There's a few other sites that I'll come back to. I'll come back to site 1 shortly. That's one of the sites that I've worked on. That's a deposit that you'll see there. You'll see the number of basically different megafauna species there. So a lot of reptiles are present here. But also because it's the consequence of predatory behaviour, it's a lot of fragments. And this is one of the key things looking at bones that I don't have to deal with, but paleontologists do, is that you have to reconstruct these animals from often very small fragments, so teeth and other things like that. But that's all I'll be talking about in terms of the bones. What I'll be talking about from now on is basically the landscape that these animals occupied. So from the pollen work that I did at this site, there's clear evidence that it was fairly similar to today. It was savanna, so eucalypt woodland basically. And we could tell that from finding microscopic pollen. So basically our eucalypt, that triangle shape is eucalyptus pollen, which gives us indications of eucalyptus trees, so gum trees, and then grass pollen on the surface there. We also have evidence of past fire regimes, so the charcoal fragments, which can reconstruct past fire events and how it changes as well, which I'll come back to. But that gives you the landscape that these animals occupied. And we can start to maybe address some of those questions about, okay, was it fire that changed the vegetation? Can we pick up evidence of people introducing fire or increasing fire in the landscape? And did that contribute to the factor? And so on. And that's what I'll be focusing on for the rest of the lecture. This is another figure, which is basically putting together a range of information from a range of sites. So that's South Walker Creek there, and that's the age of the fossil bones. We have some evidence of changes in hydrology. So this is monsoonal activity. So you can actually see it drying out around that extinction period. We see evidence of Lake Mungo of also becoming much more unstable. So generally drying out, but probably flooding events and drought events as well. That's Cuddy Springs, which is the megafauna site I mentioned before. But again, evidence of reduced discharge. And then at Lake Eyre also. So there seems to be something happening with the climate at that time period that in association with people, that's my theory, but with people basically cause megafauna to disappear. And I'll come back to this site. This is the ODP 820 site, because this is actually the data that I generated for my PhD, and put that evidence from that site in a little bit more detail. So again, with the South Walker Creek site, I extracted the pollen from the sediments in which the bones were found. And that's fairly rare in Australian palynology. There's a whole range of reasons why pollen doesn't generally preserve well in those environments. The key issue is oxidization, so exposure to air. So once that occurs, there's generally low likelihood of a lot of pollen being found. I had found enough to sort of give us that savanna vegetation in association with the bones, but not enough to sort of look at the variability across different ages of that area. There is a lake nearby that we're hoping to core that will give us that information. So what I work on are wet areas. This is a coring trip to Wellesby Lagoon in 2015. That was with the University of Adelaide, using a drilling rig, which you can see there. And from Wellesby Lagoon on Nostroprak Island, we got around about 13 metres of sediment, which goes back around about 130,000 years. So this is one of the sites that can actually address the megafauna debate as well. So there's a PhD student, Hadi Kad, who's completed it a couple of years ago, who has worked on this site. She has done some work on the palynology and suggested that people didn't have a role. There's another site basically around about 5 kilometres away, Fern Gully, which goes back about 280,000 years, over 10 metres. There's another PhD student from the same institution who found evidence of megafauna, and he suggested that people did play a role. So these are two sites 5 k's apart, which I think really illustrate the sort of debate with two different students coming up with two different results, basically. So it's only when we get a number of sites, these old sites coming back, that will allow us to sort of get some more insight and answer that question, I guess. And that's essentially, so I like mud, is essentially that slide. So that's generally what I work with. That's the title slide I showed you. That's us coring at a site, Surrey Hills in Tasmania. the depths of winter. That we did actually have snow the day after we were coring there. But basically, that's a nice peak section. That's sort of the best you can get in terms of a pollen record. So lots of pollen, very acidic, very anaerobic, so lacking in oxygen, and lots of pollen are present there. Surrey Hills is also really important to debate because this is a key site that Rhys Jones, an archaeologist from ANU, developed the plastic farming hypothesis. Bill Gamage has sort of pushed that further in his book, The Greatest Estate, and Tim Flannery also touches on that as well. So we're looking at that to sort of get an understanding of human interactions with the environment and shaping these landscapes. But the other site I'll go to is a bit further north. So again, much nicer site to be doing field work in July. Lynch's Crater. So this site was initially examined by my PhD supervisor, Peter Kershaw, in the 1970s. As part of my PhD, I did do a little bit of work on there as well, and basically tying down the age. But this is probably one of the most famous or infamous sites, depending on your point of view, in Australia. It has played a key role in providing evidence of human arrival in Australia in terms of changes in fire regimes and vegetation that's been linked to human arrival. It's also provided some indirect evidence of megafaunal extinction that I'll come to shortly with the next slide. It's on the Atherton Tableland, and again, why I'm saying it's infamous is it's a fairly atypical site in Australia because this is tropical rainforest, and you think of what most of Australia is like. So whether this is reflecting what's going on across broader Australia is up for debate. But it's really important. So it goes back around about 200,000 years, 220,000 years, and high resolution record. It's a peat swamp at the moment. Unfortunately, we've lost the last 10,000 years through peat mining. So that's used for potting mix. But there are lake sediments and other things there. So there's a lot of work that's being conducted about it. Now, where it comes into the megafauna debate is some work undertaken by a PhD student at Peter's, Sue Rule. There was a paper that was published in 2012, which was looking at this little microscopic feature. This is a dung fungus spore. Basically, if you remember fairy rings and cattle, and it's basically equivalent of that. So it's preserved in the sedimentary record. And if you get a lot of that, you've got a lot of dung, and you've got a lot of megafauna, or large herbivores, basically, is the premise of that. So Sue basically looked at the record and determined that there was a sharp decline in basically Sporomelia, which is the name of it. There was also a sharp increase in charcoal and then dramatic shift in vegetation. So here we have rainforest, and particularly dry Araucarian rainforest. So think of the Bunya Mountains, basically, which was prevalent across the Atherton Tableland at that time period. It's a fire-sensitive taxa or community. The basic premise is people arrived, they burnt the landscape, and they converted that landscape from this dry rainforest into savanna, basically, you've got savanna at that time period. And in association with that, we see this drop off in Sporomelia, which suggests the megafauna disappeared. They suggest that basically that the megafauna disappearance may have been part of that increase in burning, because if you've got these large animals that suddenly disappear, that eat a lot of vegetation, then that's going to allow fuel loads to build up and sort of promote increased burning, basically. And that's the basic premise. So now all palynologists are looking for that little thing, that little dung fungus spore, to sort of try and get an idea about megafauna extinction. And as I'll come to Tassie, and that's why I'm bringing Tassie, it's a little bit more complicated than that relationship. In addition to that, you can also see an increase in Sporomelia associated with European settlement. So more recent work that I've been involved in, you actually see it picking up with the introduction of cattle and sheep as well. So it can be used as an indicator of European settlement of Australia as well. So that's where I link up with the megafauna.
Sorry, on that slide, where does the depth link up to the age?
So basically, you've got an age here, 41,000, 40, and about 39,000. And so you see it dropping off, then coming back. I'll give you a better story from Tasmania, or a similar story to that as well, shortly.
Are you going to do the why it's coming back? Because
I'll come back to that. I'll come back to that because I think Tassie will explain that, and context is really important. And there was a lot of debate about that as well. So basically, Queensland and Eastern Queensland, I reckon, is a really important region for addressing this debate. And there's a few reasons for that. So we do have some long-term sites from northeast Queensland and central Queensland, so South Walker Creek, but also Lynch's Crater and a site that I'll talk about shortly, ODP 820. There's current research from southeast Queensland. I think is going to be really important for answering this debate. And I've already sort of alluded to some of that, but on Mildura and Australian Island, but also Fraser Island and probably Moreton Island as well. And one of the more new exciting research that's coming out, and a current PhD student of mine, Peter Negus, is that we have actually ways in which we can get information from inland sites. And these are related to inland spring systems. And this will actually, I think, potentially help us to sort of pin down and provide more data sets. So I'm going to talk about two sites, Abercorn and Edgbaston Springs. And this is very preliminary results, but I think really encouraging results as well. Now, why? Now, last week, and this talk really coincided really well for it. So you might have seen a lot of press about Indigenous superhighways of settlement for Australia. And basically that these were areas that match some of the routes that we use now that allow people to move across the continent. And this was based on modelling. So that's the paper there. It's in Nature Human Behaviour, and it used modelling basically based on archaeological sites to predict where people were moving across the landscape and basically settling across Australia. So this is probably the key slide of that. So we see people, and there's two proposed entry routes. So basically the Kimberley region or Papua New Guinea. That's still being debated. But basically we see these areas that act as superhighways. The red dots are archaeological sites. So you have the Northern Territory archaeological sites, so 65,000. There's a couple of sites in the Kimberley, which go back about 55,000. So that age is being pushed back. But you'll notice a massive gap with one of the superhighways in East Coast Queensland. So we have one site, Mount Mulligan, in just near Cairns, and that's it. So, you know, this model suggesting this is where we should be finding evidence of human archaeological sites. And basically, this is where we should be looking at. And I'll touch on some initial results about that shortly that are coming out that we might be starting to look at. All right, so I'll move on to my PhD, but also it's a project that never ends. The sediment record that I'll discuss is part of the ocean drilling program. This is an international consortium which basically goes around the world's oceans and drills deep ocean cores. And the core that I'm talking about, ODP 820, was collected as part of a program to assess the age of the Great Barrier Reef, but also preserve fossil pollen there. And why that was really important was in terms of helping to match up with the Lynch's Crater record. So that was the premise of my PhD, but also resolving a key issue as well. So it's located about 40 kilometres due east of Cairns in about 280 metres of water. So it's always covered with water, which is good. It's, well, as I said, taken part of the ocean drilling program. That's now been replaced by the International Ocean Discovery Program, or IODP. And Australia is a member of that. We contribute that, and we basically, that allows us to send scientists to go on cruises. If you're really successful, maybe get the ship to come down and collect cores for you. So these cores were collected in the early 90s, but are still being worked on today. And as I said, they're used to investigate the formation of the Great Barrier Reef and evolution and development of the Queensland Plateau. It didn't answer the question about the Great Barrier Reef, so there's still a lot of debate about that. That's another story. Now, 14 cores were taken as part of the ODP leg 133, which ODP 820 was part of. And we are working on those, so we've got records that go back in the Pliocene, so about 3 million years ago. I think the ODP 820 record probably goes back at least 2 million years plus. It's 400 metres. I've worked on the top 500,000 of it, basically. So at least 1.4 million years, probably older. And I've got to about 160 meters of that. So I've got a little bit of way to go, but it's probably starting to shift into more of a retirement thing as well to finish off. So that's a vessel, that's the drilling ship, the Geordie's Resolution. So based in Texas, but basically cruises the world and collects literally hundreds of meters of sediment records, which you can see being worked on there. So the ODP 820 record is located here, so off the Grafton Passage from Cairns. There's Lynch's crater. We have the area of rainforest, which is that sort of creamy colour. The savanna, basically inland here. And then we have areas of swamp, which is floristically very similar to our rainforest. So basically, we can look at how that's changed over that time period through pollen, which is washed to the site. And that's the 500,000 year record. So it goes back to marine isotope stage 13. I've actually got it back to isotope stage 16, which is 630,000 years. But one of the interesting things we see with this record, this is obviously an isotope record, which gives you information about sea surface temperatures, changes in salinity, changes in ice volumes and sea levels as well. But you'll notice that shift there, and that's been suggested to be an indicator of about a 4 degrees increase in sea surface temperatures at the time period. There's a bit of debate about that as well. We also have evidence of changes in mangroves. So those peaks in mangroves reflect transgressive periods of sea level rise. But the key areas here is changes in our rainforest gymnosperm. So that's equivalent to our bunya forest. And you do see it sort of being much more prevalent up to about 40,000 years ago. But there are some interesting dips in it as well where it does recover. The green is the rainforest dominates the region today. And the sort of maroon colour is the savanna country in combination with the sclerophyll herbs or grass. But you see it really picking up around about 170,000 years ago. You also see pteridophytes or ferns dropping off. And then our charcoal peaks. So I was originally brought in here by Peter to look at this charcoal peak because he found it in his pilot study, and he basically suggested that it reflected early human arrival at about 130,000 years ago. And archaeologists weren't happy about that. So basically, yes, I found the charcoal peak, but no, I don't need to involve people. What we think is going on is long-term climate change, probably linked to the development of the settings for El Nino Southern Oscillation events, so long-term drying, which is also probably related to the formation of the Great Barrier Reef. And if you look at the change in vegetation, the vegetation changes first, then we have the charcoal peak. So if it was human action, you'd think that the charcoal peak would be first, and then you'd have basically the change in vegetation. And we do see that to some extent over the last 45,000 years. So I think people are involved there. But we have a couple of really interesting changes earlier. So here, drop off in ferns, and that gradual decline in rainforest gymnosperm. So it seems to reflect long-term drying trend. And this just sort of reiterates that point. So there's our first change. There is recovery, and I think that's a sea level event. So maybe higher sea level, knocking out the forest on the continental shelf, but then it recovers from that. We then see that change there, which I mentioned before, which is decline in ferns, but also in palms. That change there, which I'm quite happy and confident, but there is some interesting research coming out of Victoria by Jim Bowler that people may have come across. It's just this date doesn't seem to die with human arrival, but I'm still pretty confident that's related to climatic events. And this top part, more sustained part, I think is people, but I'd actually argue there is a climate factor in, and that's what Scott Hocknell was using in that graph before. So one of the advantages of working on marine records is I can look at marine environmental evidence, so I have some isotope records. So there's evidence from that of a 4 degrees increase in sea surface temperatures, though there is a bit of debate about that as well, about whether that's real change. But it suggests the Great Barrier Reef developed over the last 275,000 years. But where I'm interested in that temperature increase is basically the fact that it could lead to development of the West Pacific warm pool, which is a key driver for El Nino events. So basically, when we have an El Nino drought, the West Pacific warm pool sort of sloshes over the Central Pacific, and the trade winds sort of disappear in reverse. And so basically, South America gets very wet, we get very dry. La Nina is the flip side of it. So, so I think that sort of provides evidence of that as an important precursor for El Nino Southern Oscillation. So over that time period, essentially. And we find other sites that are sort of suggesting that. So sites like Mount Etna, where Scott's also worked on the smaller critters, not necessarily the megafauna, but basically changed from rainforest vegetation to desert vegetation over that time period. So it's literally going from rainforest to desert, not savanna, but desert at that time period, then coming back to savanna. And Lake Woods and a few other records sort of suggest that something's happening at that time period. And he's referred to it as the Mid-Bruins event as well. And we're doing some more research across Australia to see if we can tie it down a bit further from marine records. So basically, yes, we see the evidence of long-term aridity with the replacement of Araucarian by savanna at that time period. We also see a couple of plant extinctions over that time period as well. So we did have Remu, for those people familiar with New Zealand, Dipydium impressinum, was in Australia, disappeared probably about a couple 100,000 years ago in northeastern Queensland. And there's a that carpet species, there's a few species around in Papua New Guinea, New Zealand as well, also disappeared. And our most recent extinction event was another Dipydium species, Dipydium wallonii, which was found in New Caledonia, or the closest pollen grain was found in New Caledonia in swampy conditions, and that disappeared around about 13,000 years ago. Interesting enough, it was also present in southeast Queensland. So from research here, we found evidence of its pollen present here. So dramatic changes between 135 to 130,000 years ago. So quite comfortable associating that with climate. But I think the change at 45,000 years is associated with people, because you see the burning first, then the vegetation change. But we've also looked at 60,000 years in a little bit more resolution, and this is based on new dates from the ODP 820 record as well. So one of the things with working in this field, if you get new dates or new chronologies coming out, it can change your interpretation quite dramatically. I'll give you another story about that shortly. So I think it's a little bit more complicated story. I think we do see evidence of people coming in at 45,000 years, but the massive change sort of is a bit delayed as well. And maybe that's reflecting the megafauna disappearing from the scene, fuel load building up, similar to what we're seeing with the recent fires as well. And that's a reference there, basically. So this is the record here. So here we see burning starting to increase about 45,000 years ago. Nothing's really happening with your vegetation. So again, that's in contrast to the other record. But then I would say it increasing up through here, and then our vegetation really starts to decline rainforest gymnosperms at about 32,000 years, and then doesn't come back, basically. So it does suggest sort of maybe a bit of a delay in that response. And obviously one of the key issues, if people are here at 60,000 years ago, you know, we don't have evidence from that record at least, so it might take a population level to start being present on the environment, or maybe climate needs to be suitable for carried fires and so on. Now, the spring systems, as I mentioned, other records that can go back over a long time period. So there's literally hundreds of them. And I'm going to talk about two springs, Edgbaston, which is sort of from this part of central Queensland, and Abercorn, which is sort of a bit closer to the coast, which provide us records that go back about 45,000 years. So yeah, some more sediment core. So this is Edgbaston. That's the radiocarbon date that we've got. So I've got about 7 dates there, or 5 dates at work. This is using Bayesian analysis to sort of give us a nice curve. But you notice a couple of dates that fall out of that. So we sort of shunt them to one side because they don't sort of fit the model, basically. So it is a bit of a dark art, radiocarbon dating and developing age chronologies and sort of bringing a range of information there. But it's actually a pretty good age model. And it actually goes back around about 40,000 years. So it's starting to hit that period of interest. There's a whole series of springs in that site. It's actually owned by Bush Heritage. And I have heard from Peter Negus that there are actually evidence of sort of cattle getting stuck in there and things like that. So it could actually be a really good site for looking for megafauna as well, because obviously as periods that have been wet for tens of thousands of years, it's going to attract animals in there and hopefully be preserved in the record as well. So there is probably another, looking for bone story there as well. This is the record. That's only a relatively short course. So it's only 90 centimeters, but it goes back about 45,000 years. Nothing really there I'd associate with sort of megafauna or people that I can see, at least initially. But there is an interesting change about 20,000 years from the last glacial maximum. So you see it shift from ferns to sedges, basically. So something's changed in the nature of the environment, maybe the groundwater there as well. But it's we need to go back and have a look at that in a little bit more detail, maybe get a longer record. Abercorn goes back over a similar time period, so about 50,000 years. We're using X-ray fluorescence. So it's another technique using geochemistry. Basically, we scan the core with X-rays, and it gives us a range of information about the geochemical content. Again, the key change here is from clays to peats. So we're interested in what's driving that. But this is a much deeper record. This goes back over 5 meters over that time period. So that might pick up more information there and over a longer time frame as well. But we're starting to apply this a lot more in terms of our sediment records. So again, I think these actually offer a really high potential for filling in the gaps in inland Queensland, which has been one of the major areas. And I think also probably provide vertebrate remains and archaeology, because these springs also would have attracted people. And Pete's also explained visiting these sites, he's actually come across stone tools and clear evidence that people have been there for a long time period. So that one is such I think should be investigated. And there's literally hundreds of them. So while these springs might pick up megafauna, I'm a little bit more optimistic for Abercorn. But I've got a PhD student who'll be working on that in the pollen record. But it gives us a good chance of picking that as well. But there are some issues with dating, which I won't go into too much detail, but there are things you need to take into account about resonance times of groundwater and things like that that may create a few gremlins. But I'm actually quite happy with those age models there, which is quite good. All right, so moving a little bit closer to home in Jiribah, I'll sort of skip over this, but essentially the key take-home message of this on North Stradbroke Island is that we have 7 sites that extend to the last glacial maximum and older. And again, these are only looking at lakes on the island or lagoons. We also have the oldest known archaeological site in southeast Queensland, and one of those sites that fills in the gaps, Wallen Wallen. So more recent research has been undertaken on this. So there's a bit of discussion about that age. It was originally published in Neil and Stock in the 1980s. People weren't necessarily happy with that age. UQ, Kayak, or Wandamuka, and Everick Heritage have been working on that site, and we've confirmed that age, so 27,000 years. We may have an older date, that's the May, but basically that date's holding up. And that's really interesting is we actually found a lot more artifacts around that 20,000 year time period, that last glacial maxima, drops off and then really starts to pick up over the last 5,000 years. And that seems to be repeated in the reanalysis of that site. We also have another potential site as well on the island. So, and that may go back even further. Native Companion Lagoon, which is the first site that I worked on when I arrived at UQ in 2004, and basically provided a 40,000 year record. And interesting enough, we do have a charcoal peak there. So maybe evidence of human arrival fits in with Lynch's crater. I do have a couple of other sites that overlap that show you a different story. So again, it probably suggests you need to look at the whole landscape, and this could well be related to humans because this is where they were. The other sites, they might be present or as present in that landscape as this site as well. And one of the sites that we're looking at is another site, doesn't go back to the megafauna time period, but is showing the potential of other sites. So this is a marsh site. It's actually right next door to the kayak offices, so really easy to sort of get basically sediment core. So we got a sediment core in 2018. And this is a site that I originally thought we were going to get pre-European and post-European fire regimes until I got the radiocarbon dates. So this is where you've got to be careful in terms of you get the dates and you can go down rabbit holes. So that date, 122, I was actually expecting to be probably around about 200 years old. You can see several orders of magnitude out. And then this date really sort of threw me because this is going back 27,000 years. And I was expecting maybe a couple thousand years, basically. So order of magnitude out from the data that we had. But that's really interesting data because it goes back over a long time period. It's an area that I would have expected people to occupy at Dunwich. So, Dunwich is there because we've got the rocks there for European settlement, and it would have been a key place for Indigenous people to probably be as well. And that's, of course, again, really nice peak sequence. It's wet through that entire period as well. So, it had permanent water source, basically. And we can also use its aerial imagery. So we can see how it's changed. So that's the kayak or old high school at Dunwich. You see, it wasn't there in 1967. It was a flat area. But you'll notice that there's actually been a change in vegetation. So paper bark swamps actually invading the site. And this is a consequence of changes in fire regimes as well. And we go back even further to 1955. So, and we can actually see that matching up with the pollen record as well. So here we have our macro charcoal count, which is large charcoal fragments, basically an indication of local fire. So you can actually see it, and this is why I thought it was European. So I thought this high peak here was pre-Indigenous. This drop off was when Europeans arrived and fire suppression came through. But as you see, I was massively out in that interpretation the dates came through. And what that probably reflects is changes in sea level. So here we have lower sea levels, and this is where Stradbroke becomes an island. And this is probably going from more terrestrial to more marine environments driving that process. And the pollen record also reflects that. But we have a record that goes back and also suggests the presence of a rainforest refugia. So these wire rush environments actually are the next areas that we're sort of focusing on. So there's Wallen Wallen. So we've actually got a lagoon site which we have dated to 18,000 years ago, so we can do a pretty good comparison between that site. Canalpin Creek is another archaeological site, and we have a marsh right next door to it that could go back tens of thousands of years. And you never know. So I could get there, get a metre or 50 centimetre core, and that's it. But based on other work done elsewhere around the island and Fraser Island, I'm pretty confident we'll get a good record out there. They'll probably go back tens of thousands of years, and maybe that period of megafauna and maybe beyond as well. All right, so I'll quickly finish off on northeast Queensland. So this is some work that I've been involved in Tassie with the Forest Practices Authority. And they sort of put me on by finding this very palaeocol. And we weren't sure how old it was, but it basically covers that period of about 50 to 40,000 years. So that's where it's located here. Now, one of the interesting things about Tassie, we've got a lot of sites from Western Tassie that go back a long time period, but it's fairly atypical. This is the oldest site in Eastern Tassie now as well. I'm also going to look at another ODP site and look at Sporamelia. Now, this site was created basically by dolerite collapsing, creating land slides, and then creating depression basins. And our site was sort of trapped in one of those. So you can see that depression there. That's basically our swamp present there. We also have really good age constraints from exposure dating. So this is dating the age of these rocks when they moved. And we have ages going back about 50 to 60,000 years. So again, that key time period of megafaunal extinction. Now we couldn't, because there's clays, we couldn't actually use our traditional coring technique. So we had to use a thing called a gouge auger, which basically pushed through the clays and then got into this nice black soil. But the key take-home message, and this is the honours project by Amira Farrell, was high Sporamelia, high burning, and it drops off between about, you probably can't make that, but that's about 50,000 years, and that's about 30,000 years. So matches up really nicely with Lynch's crater. So if I was that site alone and Lynch's crater, we could say, yep, people got Sporamelia, and we also have a vegetated eucalypt forest landscape, and yeah, but the other site, this site, which is a marine record, has Sporamelia increases over the last 15 to 20,000 years. And this is some of the problems. So if we related Sporamelia to megafauna, you've got to be, and that could well be what's occurring at the site. This site, it's being probably driven by changes in transport mechanisms. So you see the increase in ferns, this category here, that reflects more river output into the ocean. So wetter conditions, fungus, as we probably know from the recent rains, like mushrooms, like rain, and they go crazy. So that's what we've got to look at in a little bit more detail. So this record will go back hundreds of thousands of years. We'll get another interglacial period probably in the next couple of months during the research, and we'll see if we see a similar pattern to that basically with Squaremelia. So it just suggests some caution need to be sort of made in terms of, you know, from one site or two sites that we're seeing this change in sort of records. So we do have evidence of environmental change in MIS4, Marine Isotope Stage 4 to 3. And we have what we could associate with human arrival and megafaunal extinction. And one of the other interesting things that suggests this region was dominated by sclerophyll forest and woodland. And the key change seems to be opening in vegetation between the dry periods and wet periods, from what we're seeing. But I think fluvial activity might be the more important driver of that Squaremelia peak than megafaunal extinction. But yeah, that's research that's going on right now, and hopefully we'll get a better picture of marine isotope stage 5, which is the last interglacial period, particularly 5E, about 120,000 to 130,000 years ago, is when equivalent to the Holocene, basically. So that's also interesting because that's a time period where we don't have people there. So there might be some interesting difference between that. There might be more rainforest, and just a bit of conjecture at the moment, and arm waving, but it could be rainforest compared to eucalypt forest at that time period, for instance, with weather conditions. And maybe fire and people is the key driver of that. So hopefully I've given you some insights to some of my research and providing that environmental context. Again, I think it's probably a bit of both in terms of the megafaunal extinction event, but again, that's still up for debate. I think long-term aridity does play a role. There was an interesting new paper that came out about around about 42,000 years ago. We had a weakening in the Earth's magnetic field, and that may have caused the climate change that we're seeing there. So that was published in Science a few weeks ago. So it's suggesting something's happening. It's an interesting time period. So, you know, the key questions we need to address the relative role of people versus climate. And again, I think Queensland is a key location for resolving this debate. But, you know, we need to be aware of the sites. We need to look at a lot of sites and see what patterns could pick up. So, you know, Lynch's crater has been used as the one site for a range of evidence, but there's more sites that sort of emerged and suggesting a more complicated story is probably the key take-home message. And I'll leave it there if you've got any questions.
Thank you, Patrick. And we will get to questions. I can't imagine the mental gymnastics that Patrick does in terms of moving between sites and enormous time periods and going back and forth. It's just amazing, the research. So over to you, questions from the floor. I'll bring this around. I'll bring this around so that we can hear. And I think, do we have any questions from Zoom? Not yet. So if you are watching this on Zoom and you wish to put a question in chat, please do so and we'll pick that up. Okay, I'll hand this around.
Many questions. Is that on?
Yep.
Good. Many questions, Patrick. But the first one is: are you familiar with Linthorpe Creek in the Eastern Darling Downs?
I'm not familiar with that site, but I know there's been a fair amount of research on Darling Downs by Gilbert Price and Julian Louise, who I can see in the audience there. He might be able to answer that question.
I don't know.
Yeah.
What was that? No. A soil scientist, former colleague of mine, was working in some detail there and became very interested in geomorphology, found various megafauna bits and pieces, passed them on to the Queensland Museum. But the people involved, this goes back to mid-70s, people involved have moved on. It was never really written up, but from my knowledge of it, it's a really interesting area just north of Pittsburgh. The other question, if I've got, hopefully I'll answer quickly. Bogger mosses in central Queensland. Anyone looking at them much?
Probably not. So I mean, it's wide open, which is one of the things. So there's more than enough research to keep me going, and plenty for students. But yeah, we're finding new sites all the time. So I've actually got another student who's going to be working on Mount Tambourine, some of the wetland systems there. But even sort of Stradbroke, there's been no work done on Moreton at all in terms of looking at the wetland systems. And we've got a bit of work on Fraser and a bit of work on Cooler, but yeah.
But there are a number of, I mean, I'm thinking Taroom area generally, particularly a number of GAB springs there that to me ought to be wonderful.
Yeah, no, the springs are probably really new area that we're getting into. So
Patrick, it may not be from your work, but what is the oldest evidence that we have that's reasonably accepted for Aboriginal settlement in Australia? I'm probably thinking Lake Mungo, but what is the oldest that we have?
So Majubibi, which is in Northern Territory, which was worked on by Chris Clarkson and the UQ team and others. So they've got an age of 60 to 65,000. It looks and standard up pretty well at the moment. That's the issue. There are a couple other sites in Kimberleys which are getting up to about 50 to 60,000 years, so it's sort of firming up. But there's still debates there. So there's Jim Allen at La Trobe University, who's sort of very keen on the 40,000. He's sort of been pushed out to 50,000. I think the weight of evidence coming out, but there are still people who sort of fully support the 50,000 date. But Majubibi is stacking up, I feel. So I think that's 60 to 65,000 date for Northern Australia. But when we start looking around, I mean, we've got nothing between basically here and Cairns in terms of the archaeology, or published at least. So I think Mount Mulligan on Narrabulben, which is the site, is around about 45 to 50,000. There's a couple of sites down in Tassie which are about 40,000, but and there's one site that Jim Boller, which I mentioned before, is working on, which is near Warrnambool, which is about 130,000 sites. But I've had a chat with the archaeologist working on that, and he sort of says it might just be seagulls dropping shells, really, something that looks like a midden and things like that. He's working on, he's done the publications, but he's very dubious about it as well. So as I said, 60, 65 is probably the new age.
That's the Kakadu one.
Yeah, yeah.
Yes.
Yes, Patrick. I was interested to hear about the ocean drilling done off eastern Queensland. Do you know if there's been any sort of work done in the Gulf of Carpentaria area? Because that would be dry land.
Yeah. So there's Lake Carpentaria was cored, and not by the ocean drilling program, but was cored in the 1990s. There is a pollen record that exists through there, and I think it goes back to about 130, 140,000 years. So we don't not only have sort of IODP program, but we also have Geoscience Australia and other groups that are sort of coring and creating these records as well. So yeah, so basically it does show that transition from a sort of lake environment to a estuarine and then the Gulf country at that time period as well.
Is that on?
Yes.
Following on from this gentleman's question, the humans that people talk about being here 40,000, 50,000 years plus, what do they look like? And how do they compare with modern people? And for example, I've seen photographs of a skull from Mungo and another one from a site on the Murray River that I can't remember the name of. And both are totally different, although they were dated apparently for the same time of existence on the planet. So what did these people look like? What were their
what were their skills? What would their ability have been to alter the landscape and the fauna in a significant manner?
I think the general idea that basically the people that arrived at that time period are basically the ancestors of the Australian Aboriginal people. And you've got to remember, even getting into Australia, you do need to cross some major border crossings. Now, I know the cow swamp site that you mentioned, there is some suggestion that it might have been created by head binding and basically altering the morphology. And you can see some even more recent evidence of that, I think in South America, of the dramatic change in head binding of young children that makes the skulls look dramatically different from sort of other closely related populations as well. But the evidence is pretty strong, and I think genetic evidence of that as well is sort of pushing that there's a direct genetic link between Indigenous people here in Australia today and the people that arrived 40, 50, 60,000 years ago, and that's confirming up as well.
Thank you. Given that a lot of this work ultimately depends on cross-correlating what's happening with the human population with pollen records and other records, how do we know whether Indigenous people might have in fact arrived well before 65,000 years ago, and yet there is no record as yet discovered? Conversely, if the populations were initially very small, it might be that they didn't reach a critical mass to critical numbers in order to be able to influence what was happening in the environment until some considerable time interval after there was an archaeological record. So doesn't that make cross-correlation between what you're describing in human populations, doesn't that make that extraordinarily difficult to do?
I wouldn't necessarily. I mean, probably one of the things we need to sort of look at is go back to first principles. And I agree with you to a certain extent. So one of the key things that we can pick up in palaeoecological records is the arrival of Europeans. It is in multiple records, it's clear cut. You see evidence of it, not only in terms of changes in bioregimes, but you can also see changes in introduction of exotic animals and plants and increased sedimentation rates and a range of different things. But you do see subtle differences. So there are some areas which are more impacted than others, and also having an understanding of the basic dynamics that are occurring there. The ideal situation would be to have your archaeological site and your pollen record. And we do have some of those sites. The cave that Rio Tinto destroyed in the Pilbara was one of the sites that I actually worked on for a consultancy project. And I actually got lots of pollen out of it. And basically, it did show direct correlations between those sort of events. So that's not what we're looking for. But I do, agree with the premise that there could be in the palaeoecological record, and that's why you've got to be cautious with Lynch's crater, but also with ODP 820 that that we've got to be with that could be present. We've got a 20,000 gap between those sites. So is that a real gap? Does it take 20,000 years for people to make it to northeastern Queensland from Northern Territory? Could well have taken that time, I'm not sure. Are there other sites out there, or are they just not being, wasn't until like 45,000 period when we had increased aridity occurring, basically to see that in the record, basically. So it's all things that we need to be aware of. And one, I'm probably going to be a little bit more cautious with some of my colleagues, basically, so about making those interpretations. But yeah, we need to look at more sites to get that idea. So we might try to take a message of that.
Are there any more questions from the floor? Yes. I was curious as to, has there been a thought about what the total population around this 40, 50,000 years ago might have been?
So the basic idea, I think you probably need about 500 people to create a viable population to arrive in Australia. And this is why it would have been a sophisticated, I don't think people just sort of turned up, they were out fishing something. They knew Australia was here, or something was there, and they kept going, and they had the foresight to sort of move there. Population, it's really difficult because I think there was a paper last week that came out that suggested that there might have been populations in Australia prior to European settlement in the millions.
Yes, yes, that's what I heard.
So, you know, I mean, I expect lower density than now, or that time period, but it could have been, you know, a few 100,000 people. It would have probably hit a crisis during last glacial maximum when temperatures dropped and with increased aridity. But again, it's looking at more sites. So there is evidence, for instance, that the Wallen site that we've got high artifacts and then it drops off. Now that could be, you know, suggesting higher populations and dropping off and populations coming back as well. So, you know, it's very problematic to get those
You're
estimates.
talking about charcoal.
Yep.
And so it must have been significant.
Yes, in those areas, yeah. But it'd be in,
isolated.
but it'd be in particular areas. So I'd imagine if you look at sort of North Stradbroke Island, I'd imagine on the sort of where the springs are, that's where people probably would have been based, and they probably would have burnt the landscape a lot more than say maybe the high dune systems, which might have been more dry at that time period. So it's like sort of, yeah, finding a needle in a haystack as well. And that's why we've probably only got one potential kill site in Australia, because there's a large continent, not a lot of scientists, and it can be difficult to find these sites.
So when did Stradbroke become an island?
About 9,000, 10,000 years ago.
9 to 10.
Yeah.
And will you be working on the bulbs on Fraser Island?
I have done some work there. And interestingly enough, we got a sediment record that goes back to that 45,000 year time period, and it was full of brute charcoal, big fragments at that time period. I've got to go back and get another core from that site. It's just something really major happened there on that site, like a massive fire event, and then basically flooding rains and washed it all into the system at that time period. But whether that's associated with people, climate change, or both, we need to do more research there.
Well, John Sinclair had the Irish people come over and confirm, yes, they're proper bulbs.
Yeah.
Any more questions from the floor? Just one more, because I think we have a couple of questions from, just one question on Zoom. So we might get yours quickly, Bob, and then we'll pull up the Zoom.
In the inland river systems, and the Macquarie comes to mind because to my knowledge it's the most complex network of relic streams in Eastern Australia anyway. Have you tried looking at clay sediments in any of the areas that look as though they've been very, very ancient water holes, and even in the surface, I reckon some I know of could go back some thousands of years? There has been a bit of work in that area. I think University of New South Wales done a bit of work. There's also been some interesting research sort of in the Murray Canyon land off the coast, which is suggesting sort of similar changes in vegetation as well. So probably our key areas in terms of palaeoecological research are probably northeast Queensland, so Lynch Crater and other sites, Western Victoria, eastern South Australia with the lake systems down there, and then Western Tassie. But we're starting to fill in the gaps. I mean, Western Australia is another area that's untouched relatively in a palaeoecological sense, but there are a lot of potential sites there, even within Perth. Like you sort of see lake systems and things like that. I mean, that's why Google Earth is fantastic for me, because I can get up down there and have a look at the wetlands and say, oh, that looks like an interesting site and things like that. And one of the reasons why Queensland's actually really got good potential is that the Queensland government's got their wetland mapping area. So generally when I'm looking at a site, I have a look and see if that been a human modified system, has that been another. I've got a site on my list actually in Brisbane near the Gateway Bridge. I think it's potentially an old site there, and the swamp system that might have been there for a long time period, potentially give us some old information. So yeah, it's again finding the time and money and students. It's probably more the important thing for me at the moment. But there's a lot of potential on sort of even mainland Queensland and around Brisbane.
Okay, look, we do have one question from someone on the Zoom, so I will read it out, and then if Patrick can answer that. It's from Stuart Watt, who is one of our members, lives in Toowoomba. Warwick, sorry. And Stuart says, hope you're listening there, Stuart. Has any evidence emerged of any influence of disease introduction, human or accompanying animals, rather than hunting or habitat change by human action. I think he means disease
Yeah.
to megafauna.
Certainly could be a possibility, but it'd be really hard to pick up. But again, we just need to look at COVID, and there's a range of other diseases that could easily have been brought in. And you know, that can really impact populations as well. And it could also be a plant disease. So there's myrtle rust, which is coming to Australia. Major issue. It's sort of the hidden issue that's sort of occurring, a lot of concern with the Myrtaceae family around southeast Queensland, but Australia in generally. So you know, it could be a plant disease that comes in and maybe wipes out that food resource. I guess if we saw a dramatic change in vegetation and we didn't see charcoal peaks or something like that, then we could start to look at that sort of disease angle, but it'd be indirect evidence as well.
Yeah, very difficult area, I would imagine. So thank you for that question, Stuart. Okay, well, I think we should really give Patrick a break here. It's been such a fascinating topic. I think there's a few thousand years of work here to be still done. Okay, so Patrick, I'd like to thank you very much for presenting to us this evening and coming along. Will you please join me in a round of applause? Thank you. And we'd like to offer you just a small token to enjoy on your field work.
Thank you. Well, actually, over the Australian my wife's 50th on the weekend. So
oh,
yes,
that's
so,
nice.
yes.
Oh, you can have that one, I think. All right. Well, thank you so much again. Now, what happens now? We have